So this is trigonometric substitution. So as the name implies, it's a substitution method wherein trigonometric functions are used. So for case number one, if a squared minus u squared, if a is a constant and u is a differentiable function of x, so if this is present, then we can use the substitution. We let u be equal to a times sine of angle theta. So from a differentiable function of x or y or any other letter, we transform it into a trigonometric function. And then we use the different formulas in integrating trigonometric functions. Okay, so why set sine? So if ever we forget the substitution, so we can always derive this equation by analyzing the sides of a right triangle. Okay, so since this is a squared minus u squared, so it must be from the Pythagorean theorem, no? I recall. Okay, the Pythagorean theorem is the square of the hypotenuse. If we have the sides A, B, and C, where C is the hypotenuse of the right triangle, no, the square of the hypotenuse is equal to the sum of the squares of the other two sides, right? So if we have here difference of A squared and U squared, so it must be between A squared and B squared that is placed on one side of the equation, and one of these two will be placed on the left side of the equation. Okay, so that there will be a difference of two squares. Now, for example, if we put b squared on the left side, so it's c squared minus b squared is equal to a squared. So meaning the hypotenuse here, okay, contains the a, no, in that a squared minus u squared. Okay, and then the either the opposite side or the adjacent side, okay, of the right triangle, okay, contains no the u. So a function of x, for example. Okay. So since this is assigned a sine, so this b here must be the opposite no side of the right triangle, because sine theta is equal to opposite side over hypotenuse. So if we have this right triangle, okay, and if this is angle theta and this is the um right angle here, so this must be, okay, the hypotenuse of the right triangle, and this is the opposite no side. Okay, so we let the a here, the constant, be on the hypotenuse of the right triangle. Okay, so this will contain no the a, and this will contain the u. Okay, the opposite side will contain the u. So again, from the trigonometric function sine theta, it's opposite over hypotenuse. So meaning it's u, okay, over a is equal to sine theta. Or if we arrange the variables, we get u is equal to a times sine theta. Okay, so we have here the derivation, no, from the right triangle to this substitution equation that we're going to use, okay, for algebraic integrands. Okay, so for example, if we have this given integrand, okay, so if we have x cubed times square root of 4 minus x squared, okay, dx. So there is no an x squared, and 4 is it can be written as a squared, so it's basically a squared minus u squared for its format. Okay, this is a squared minus u squared. So a therefore no is 2, square root of 4 no is 2, and u therefore is x. Square root of x squared is x. So we are going to use, okay, the substitution x equal to 2 times sine of theta. Sorry. Okay, so how do we do that? No, so why is it again sine? So we go back to the right triangle. So before we proceed with the solution, so let's draw no, the right triangle. Okay, so for example, if we we use this kind of triangle, so we'll have the opposite side here. Okay, instead of going on the other direction. Okay, so if you draw the theta, okay, on this location, so meaning this is the opposite side, no, and the one opposite to the 90-degree angle, okay, is always no the hypotenuse of the right triangle. Okay, so again, if you cannot recall, no, the substitution equation u is equal to 8 times sine of theta. So you analyze, okay, so it's should be 4 minus x squared. Okay, so meaning the hypotenuse must contain no, the square root of 4. Okay, and the opposite side of the triangle must contain the x. So therefore, okay, the hypotenuse is 2. Okay, meaning the a, no, and then the opposite side is the x. Okay, meaning the u. So we use the relationship. Okay, we have sine theta is opposite side again over the hypotenuse. So it's equal to x no over 2. Okay, or solving for x, we have 2 times sine theta. It's basically just the same thing. Here, no, we let u be equal to a times sine theta. So you need to analyze, no? Do not always memorize. So analyze. Okay, so if you're not sure of the substitution equation, so again, you can always go back to the basics. Okay, use the Pythagorean theorem and the different trigo functions. Okay, by writing or by drawing a right triangle. So this is u is equal to a times sine theta. Okay, so after solving for x, solve for dx because you'll be needing that no for the integrand dx rather. Okay, so dx is 2 no times cosine of theta d theta. So we can now replace dx and x cubed, okay, with these expressions and then solving for the square root of 4 minus x squared. So solve for square root of 4 minus x squared. Okay, so the third side of the right triangle, no, the adjacent side contains no, that radical. So this is the adjacent side. Okay, so if this is 2, the hypotenuse is 2 and the opposite side is x, so meaning the adjacent side is square root, okay, of 2 squared, or that's 4, no, minus x squared. Okay, so from the Pythagorean theorem, no, the square root of the square of the hypotenuse minus the square of the opposite side is equal to the adjacent side. Okay, so we need to transform the square root of 4 minus x squared into a trigo function. So we must pair it with one of the two sides. Okay, it's either the 2 or the x. So it would be best if we will choose the constant because we can easily, transform it into trigonometric functions. If we choose the x, then we need but to assign, okay, or change it to 2 sine theta, which makes it more complicated. Okay, so we'll make things as simple as possible. So to transform this to trigo function, okay, so choose the side which contains not a constant. So of course we put the variable, no, square root of 4 minus x squared on top, and then at the bottom, the denominator is the constant. Okay, so basically, no, this is the adjacent side, and 2 is the hypotenuse of the right triangle. Okay, so the trigonometric function equivalent to adjacent over hypotenuse is cosine. Okay, cosine of angle theta. So square root of 4 minus x squared all over 2, therefore is equal, okay, to cosine theta. Or square root of 4 minus x squared is equal to 2, no, times cosine theta. So we now have, okay, these three, okay, equations. Three equations, no, 1, 2, and 3. So we can now replace the variables x, okay, with theta. Okay, so for the solution, so let me rewrite now the given here at the bottom. So it's x cubed times the square root of 4 minus x squared, okay, dx. So we write 2 sine theta instead of x. And we are going to raise it to the power of 3. Okay, so this is from equation 1. And then from equation 3, so we have 2, no, cosine theta. Okay, this is from equation 2. And dx is from equation, or rather, this is from equation 3, not equation 2. Okay, equation 3. And from equation 2, we have dx. So we have 2 cosine theta d theta. Okay, again, this is from equation number 2. So everything is transformed into theta. So we now simplify. Okay, so this is 2 cubed or 8, and then sine cube, no, theta, times 2 cosine theta times 2 cosine theta d theta. So we put the constant, okay, outside, then focus on the triangle function. So 8 times 2, that's 32. Okay, and then we have sine cube and a cosine squared theta, d theta. Just now being transformed, no, into trigonometric functions. So we use the formulas, no, in solving trigonometric integrands. Okay, so if we have sine cube and cosine squared, so if you cannot recall those methods, those cases for solvable groups of trigonometric integrals, then you analyze. Okay, so if we transform this to sine, would a du be present? If we transform sine to cosine, would a du be present? Okay, so if we have, no, sine cube and cosine squared, we can put, okay, one of the three sine thetas, okay, para ready for the du, and then transform the remaining, okay, sine squared into cosine squared, and combine it with the cosine squared here, and then the factored out sine will be ready for the du. Okay, so we put one sine theta here, ready for the du. So what we have left is sine squared and cosine squared, no, theta. So we transform sine squared to 1 minus cosine squared theta using one of the Pythagorean identities, and then multiply it with cosine squared, no, theta, sorry, and then sine theta d theta. And then multiply cosine squared theta to 1 minus cosine squared theta. So that's cosine squared theta minus cosine raised to the power of 4 theta. Okay, then sine theta d theta. So we use the simple the substitution. We let u be equal to cosine theta. So du is negative sine theta, not d theta. So we need a neutralizing factor of negative 1 because there's only sine theta d theta. So we need a negative 1. Therefore, this can now be transformed into negative 32. Okay, times the integral of u raised to the power of 2 minus u raised to the power of 4. Okay, and then the du. So we integrate. So the integral of u squared, that's u cubed over 3, or that's 1/3, no, u cubed. And integral of u raised to the power of 4 is 1/5. Okay, u raised to the power of 5. And then the plus c. Then return the trigo function. Okay, that's 1/3 times u is cosine. So this is cosine cube. Okay, theta minus 1/5 cosine raised to the power of 5 theta. Okay, and then plus c. This is not yet the final answer because our original variable na is x. Okay, so we need the cosine theta transformation. Okay, so we have here cosine theta is square root of 4 minus x squared all over 2. So we'll use that. Okay, so from equation number 3. So from equation number 3, okay, square root or cosine, no, theta is square root of 4 minus x squared all over 2. Okay, so we write that here. So it's negative 32 times 1/3, and then we have square root of 4 minus x squared. Okay, all over 2. Take note, we need to raise this pa to a power of 3. Okay, and then minus 1/5, and then square root of 4 minus x squared. Okay, all over 2. All over 2. Quantity raised to the power of 5, and then plus c. Here, that's negative 32 times, okay, that's 1/6. I'm sorry. 2 cube is 8. So times, it's 1 over 8 times 1/3. So that's 1 over 24, no? And then we have 4 minus x squared, okay, raised to the power of 3 minus 2 raised to the power of 5. That's 32. 2 times 2 times 2, 8 times 2, 16 times 2, 32. Then times 5. So 32 times 5, that's 160, no? Times 5. Okay, so 160. So 1 over 160 times the square root of 4 minus x squared. Okay, quantity raised to the power of 5, and then plus c. So you can have this, the final answer, or distribute, no, the negative 32 to each of the terms here, or some would factor out, okay, the common factor, cosine cube. Okay, you can also do that, okay, as long as it would be equal, no, to this expression. Okay, so you need to restore the original variable. So this is the answer for the integral of x cubed square root of 4 minus x squared k dx. So that's for case number 1.